Thank you very much for joining. Today we have a TRACCS webinar offered by PROTRAN Technology. The title of our webinar is Roadway Worker Protection and Truck Intrusion Detection Systems. Thank you everyone for joining. And before we start with the webinar, I would like to inform you about some other upcoming webinars and some other information that you will find useful regarding TRACCS Rail Day, which is only 6 weeks away. As I said, today we are going to be focusing on roadway worker protection and truck intrusion detection systems. Our speaker is Jamie McGuire. She's a Senior Director at PROTRAN Safety Solutions. And we'll hear from her in just one moment. Next week, same time, Tuesday, May the 14th at 12 noon, we have another upcoming webinar, this time focusing on human resources and overcoming hiring challenges in a limited resource industry by Live Assets Transit Staffing Solutions. And then we also have another webinar planned for May the 28th at noon as well, noon Eastern time, for the future of global rail renewals, a transformative approach. This webinar will be offered by Tom Maxwell from Uniport Rail and David Thompson from Thompson Engineering Design. So if you want to sign up for any of these webinars, you can go to our website, www.traccs.ca, and if you scroll down, you'll have the option to register for all these webinars. Now, without digressing too much, some of you may know we have some important work being performed on the Canadian Transit Rail Standards Development Program. This is a new endeavor here from TRACCS, and we are on the very early stages of development, and we are going to be working in partnership with the Canadian Standards Association. You can find out on our website at traccs.ca/standards. You can also email us if you want to know more or register to volunteer for that program. Now, something everyone's been asking me is, when do we have the conference schedule for Rail Day? The full conference schedule is already posted online. The morning and afternoon sessions already have themes, as you may already know, but you can go to traccs.ca/speakers to see all the sessions, and you'll have a chance to see Jamie McGuire, today's presenter, in person as well at the show. You can get your tickets to attend from traccs.ca/TRD tickets. All these links are on our website, so you can visit that as well. Our sponsors for Rail Day are essential to us being able to put this show together, so we are very grateful to all our sponsors. You can connect with them through our website if you go to traccs.ca/Rail Day 2024. And in a few days' time, we have an info session for exhibitors. So if you are an exhibitor and you were not aware, May 9th at 11 a.m., there is an info session. If you're an exhibitor, connect with us, connect with your team, and we will share that link for you. Now, without further ado, we have here Jamie McGuire from, she's a Senior Director at PROTRAN Safety Solutions. And she is an expert in the matter. Jamie is has been working in this section of the industry for more than a decade. So PROTRAN Technology is a hard-scope rail company, and they offer a wide range of safety and measurement products for the rail industry, including roadway worker protection, industry intrusion detection, collision avoidance, and track geometry measurement tools. Jamie has been with PROTRAN technology for more than a decade, and during that time, she's had the opportunity to work directly with Class 1 Rs and transit across North America, implementing the PROTRAN safety solutions, helping to keep track of workers and passengers so that they are all safe. So welcome, Jamie. Thank you so much for joining us today, for being able to let us know what is going on with this new technology.
Great. Thank you so much, Andrea. I appreciate you giving me this platform and allowing me to present our systems to everyone who's interested. With that, I'm going to go ahead and share my screen, and we'll just walk through a PowerPoint. I'm going to give a very high-level overview of many different types of solutions that we offer. We'll have a question and answer session at the end. So if you do think of a question, you don't want to forget it, just put it in the chat, and then we can take it from there at the end of the presentation.
Thank you.
Sure. I'm used to using Teams, so I'm going to go ahead and try to share here with Google Meet here. There we go. And everyone can see my large screen. Andrea, can you see my main
Yes, we
screen?
can see your screen very well.
Perfect. Thank you. Alrighty. So as mentioned, PROTRAN Technology is a division of Harsco Rail. We were acquired by Harsco Rail in 2015, and prior to that, PROTRAN had already been servicing the rail and transit industry with safety solutions since the early 2000s. So we've been around for about 20 years now, specializing in technology systems to offer safety and measurement products. Here's a list of some of the different types that we offer that I will be reviewing today. We offer a lot more than this, but we're trying to keep the focus on the roadway worker protection, collision avoidance, and also wayside and intrusion detection systems. So as mentioned, PROTRAN has been serving the rail and transit industry for going on 20 years with different products, but over 15 years of revenue service with our roadway worker protection systems. We've come a long way. We've had multiple different models and generations that we've developed and deployed over time. And a lot of our system today, or a bulk of how our systems work today, is based off of several years of customer feedback through the industry from using our systems. And as technology improves and becomes more available, and then we, constantly upgrading and improving our systems. And today they're made to be scalable and configurable. This list is some of the current customers that we have using our roadway worker protection systems and our collision avoidance systems as well. So why add a secondary roadway worker protection system? Everyone has a standard operating procedure to keep their workers safe, but we all know that at times those procedures fail due to fatigue, complacency, just poor communication tends to be the number one problem when there is an incident or an accident. Somebody says the track is clear, go ahead and start work, and then here comes another train or a piece of equipment that wasn't supposed to be on the tracks, right? So that's where the secondary layer of protection comes in and picks up where the standard operating procedures failed. So your single point of failure would be just having that flagger, lookout, or just using communication as your only means to protect your workers. When you deploy a secondary system, it's going to provide this warning of the train approaching no matter what, even if the communication was wrong or your flagger is not paying attention, your lookout watchman is not paying attention, or there's also other factors, you know, when it's very cold or very hot, you know, sometimes standard technology whistles don't work, or if it's very hot, there can be very, you know, strong fatigue. These systems don't have those issues. You know, they're going to alert every time, no matter what. So it does provide this redundant layer of safety when implemented with your standard procedures, provides an additional layer of protection to the workers and vehicle operators as well. And it does not replace workers. You know, so this is a tool that is provided and should be used with the workers to make sure everyone goes home safe. Our systems do provide data logging of the events, the activation of events, the alert events, and the confirmation events, so that that information can be used for your safety management system, as well as you track your near misses and other incidents. And our systems have been proven to mitigate accidents and save lives. So I'm just going to go over the couple different types, and I'm going to start with our portable roadway worker protection kit. The portable kit is designed for contractors who cannot install equipment on the trains or wayside, and for railroads or transits that have shared quarters but cannot install permanent wayside detectors due to infrastructure limitations. It's a reliable system. It does require setup and takedown before and after each shift, and charging of all devices after each shift. The portable RWP system, Roadway Worker Protection, RWP system, provides advanced warning to the track workers of an approaching train. It is battery operated, and you would temporarily mount it on or next to the track, and the train detector, which would communicate with the worker personal alert devices and the portable warning horn and light crew devices to notify the workers when the train is approaching. The setup and takedown does take just a few minutes and can be implemented within your standard operating procedures. So for instance, when you're putting out your more advanced warning boards and stop boards, that's where you would set up your train detector and then your first horn and light at the start of your work zone. You can see in the application drawing, the portable train detector is set out by where the train is about to pass it. It does use sensors to trigger the system, and then it will send the alert via radio communication to the worker devices. Our portable train detector uses directional sensors that provide accurate alerts in various work zone configurations. Directional sensors allow you to have 2 train detectors set up on one track at the start and end of your work zone, and the alerts will only activate when the train is entering the work zone, not when it's exiting the work zone. And that way, if you have reverse traffic on your active track, it'll only alert when the train is, like I said, going into the work zone area and not when it's leaving the work zone area. This provides protection when there's single tracking or when you need track specific alerts with multiple work zones, adjacent track protection, and so on. We have tested our portable kits at over 150 miles per hour, and no issue there at all with the directional sensors. The system utilizes a handshake, a communication handshake. That way it will confirm that at all times it'll constantly be communicating, the train detector communicating with the portable warning horn and light device. That's this small boombox device. And if the boombox does not get the handshake signal from the train detector, it will go into a different alarm, a loss of handshake alarm, letting the workers know that they are not being protected by the train detector. That would happen if you set your devices up too far apart, so there's no signals, the signal strength is poor, or they just are not making communication, or if you did not charge your train detector device and the battery died or something like that. It does have a battery status indicator, so you know that the battery is full before you take it out, but if for some reason you did not charge it and it should die, then you would get the loss of communication alarm, so you would know that you're not being protected by the train detector, and you would either, just go figure out what's going on at that point. All of the portable warning horn and light boombox devices also act as repeaters, and you can use as many as you want in the work zone, and you can use them to extend your work zone as far as you need. They're mag mountable, so you can mag mount them to the track, you can mag mount them to equipment, you can mag mount them to catenary poles, anywhere that's convenient and near your work crew. We do provide a charging case for the equipment that the parts can go into the case and have a quick connect to just plug them in, and the case just gets plugged in with one plug. This is a picture of the devices. So this is the train detector. This does have to be mag mounted to the web of the rail. Unless it's embedded track, then we have a different laser system that's just not mag mounted, but the same idea, just has to trip the device. It can sit on a tripod. And here's the horn and light devices, and these are the personal alert devices. This is our standard personal alert device. We call it a pad. It has the alert button, or some have a confirmation button, depending on what system you're using. And then this is our RWIC flagger device. It has the alert and the confirm button. So this can silence all alarms. This is the charging case. All the devices, like I said, have a die cut position. They just slide right in, quick connect cables, and close it up and plug the case in at the end of the shift. So it's real easy to take out and bring back in. That's it for the portable train detector system. Now we're moving on to our train-based system. That is what we call our ranging PROTRAN roadway worker protection system. We call it our ranging system because it utilizes ranging radio technology to calculate the distance from the train to the workers ahead. And I'll show a little bit more on that now. So the train-based system is designed to be extremely user-friendly, and it is the best option for transits with dedicated corridors. Once it's installed, there's no additional setup on the tracks needed for daily use. When the train is powered up, the ranging PROTRAN system is also powered up and ready to go. The operator does not have to remember to turn it on, and they cannot turn it off. There's no additional wayside equipment required for the ranging train-based RWP system. So with this system, it includes a device that is permanently mounted on the train that communicates with the device worn or carried by the workers on the track. So this is the train unit. Actually, I have one here. If you can see, I can't see myself, so I hope you can still see me. So there is the train unit is installed in the cab of the train, and that is the device that's actively looking for the workers ahead. We can provide distance-based or time-based alerts, factoring the speed of the vehicle for consistent and accurate warnings. It uses the train speed to do the time-based alerts, and that's based on the train unit's GPS. So for instance, you could say, we want to always provide our workers 25 seconds advanced warning before the train reaches the work zone or the workers. And no matter how fast or slow the train is going, they're going to get that 25 seconds advanced warning. Or you can say 30 seconds or 50 seconds, depending on what you want to give your workers. It's configurable. It's completely up to the customer. For example, RTD Denver provides 20 seconds. Valley Transit Authority provides 25 seconds, and Edmonton Transit, I believe, is providing 30 seconds advanced warning. So it really depends on your system, how fast your trains are going, the type of work your workers are typically doing, and you can fit this into your operating procedures, however works best for your system. The system does have a power on self-test. When it starts up, it will check all of the communication signals that are in the device, and as well as the antenna connections, and make sure that the signal strength is at what it should be. And if there is a failure of some sort, it will relay that information to the operator on the display screen with an alarm, and they have to acknowledge that alarm to be able to clear it. We have hundreds, if not thousands, of these in operation of this version, and I can tell you less than a handful have ever come back for any issue. And if there is, and we need to replace it, you simply unplug the device, send it back, and pop in a spare that you would just have on hand, and you keep going. So there's no delay or stopping of revenue service if you needed to make sure you had one of these on every train. It's very easy, plug and play. The system also does provide data logging of all events. So every time there's an alarm sent to workers, it will data log that. It will data log when the worker confirms that they received the alarm via their worker personal alert device. And it will data log when the operator also acknowledges that they received the alarm that there's workers ahead. And it data logs, so it's going to data log the date, the time, location, and the speed of the train when all of that was happening. And I'm sorry, it will data log when the worker got the alarm and also when they confirmed the alarm. As mentioned, this system is super easy to install. It's just a couple components, takes no time at all, and then you're good to go, and requires bare minimum maintenance on a regular, basis. Super easy to use. So this is a little bit more about this system. The train-mounted ranging PROTRACKR system will provide the operator an audible and visual alert of track workers ahead who are wearing the personal alert device. So I'm going to stop right here. I hope you guys can still see me. I'm going to just turn this on. If you can see this device, this is the double screen. It's got a little heartbeat letting the operator know that it's working and looking for workers. Right now, there's no workers ahead. As soon as I turn on my personal alert device, it will show up as an unconfirmed worker. And once I hit the confirm button right on the front, that will pop up to the top screen, letting the operator know that I have cleared to a place of safety and it is safe for them to proceed through the work zone. And that's the key. And this, as you can see on this screen here, the numbers are showing how far away the worker is. I'm going to mute this for a second. So we're unconfirmed. And as soon as I hit the confirm, it will silence this, changes the light bar so the worker knows it was confirmed. And they moved up to the top screen showing confirmed. I'm right here. I'm inside. I don't have antennas hooked up, so I am 0 feet away, but that's why it's showing 0. The zeros would be the distance, how far away the track worker is to the train. And the reason it's counting down is because, or showing the distance is so if you do have an unconfirmed worker that you're getting closer and closer to and they still don't confirm, you can put that in your operating procedure to say, hey, if you get within 200 feet of a worker and they're still not confirming, stop and call dispatch or whatever your SOP would mandate at that point. So that's the positive communication between the workers to the train operator that they are in a place of safety. One thing I cannot show you because I don't have 2 units with me, but the system does provide a discernible second train audible and visual warning to the track workers. That would be, you just heard the alarm they got, you saw the light bar was blue and then amber and then went white when it was confirmed. It'll be flashing blue before it gets an alarm, and then it goes to, and then if a second train comes, it'll go to a different color scheme and it'll actually sound different, so they'll know it's another train. I know it's another train because the units themselves are sending their serial number along with their code. That's how it's data logging the specific train alerts. But for the workers out on the right of way, they, for human factors purposes, they asked for this, they say it's the second train, that's always the one that you're not expecting, and they didn't want to have to ever question, is that the train that just came through when they hear an alarm again? Now they know for sure that it's, another train, the next train. So it's always going to flip flop from one alarm to the next when there's a second, the next train coming. And that was a added feature that one of our customers asked for, and we built that in, and now everybody has that option to have that feature. This is just how some of the system basically works. So it's using the ranging radios along with, that's a 2.4, along with 100 megahertz, using directional signal and also GPS for the train speed and data logging.
Jamie?
Yes.
There's a question here that I think would be good to address at this moment.
Sure.
Buddy is asking, I believe all these safety devices and accessories are internet dependent. If the connection is poor or not reliable, is there plan B for maintaining the desired level of safety?
Sure. So they're not internet reliant. They are radio based. So we have, it's a dual redundant radio system. We've used 2.4 gigahertz and a 900 megahertz. So the 2.4 is used for the ranging and the 900 megahertz is used for the data packet, and that's at a high power output. We are secondary, so there is a chance that you would not get that radio signal, but we've done testing with a spectrum analyzer at all different agencies in all different scenarios, situations, urban canyons, real mountains, different terrain, wet locations where it's heavy rain or snow. As I mentioned, we use this up in Edmonton, Canada. Wet conditions depletes radio signal, and even in that environment, we've had no issues at all. If there is a spot that we do find, like a spot in your system that just has poor signal communication, we put a repeater in at that point, and that will just basically be permanently mounted repeater, and it will take that signal from the train unit and repeat it to workers that may be down the tracks ahead. So when we've only had to do a few of those in very remote areas. So that's basically it. But
that's fantastic. Thank you for clarifying that.
Sure. Thank you for the question. So here's this is the screen. I don't know if you could really see my unit well when I was showing the example, but this was basically the same thing. Here's the ranging pro tracker. The top screen is clear. The bottom screen shows 2 unconfirmed workers. As the workers confirm their device, they will pop up to the top screen. And so really all your train operator has to pay attention to is to make sure once they start getting alarms and see that there's workers ahead, that the bottom screen stays clear. So the unit's doing all the work, it's looking for the workers, it's letting everyone know the train's coming, and we're trying to keep it as simple as possible for the train operator because we don't want to give them more work. So all they really have to do is pay attention to that bottom screen and make sure it stays clear. This is an example of our data log. So basically it's, here's the timestamp, here's the sorry, it doesn't have the serial number. Yeah, here's the serial number, and then the asset, we can put what train number it's on. So here's the event, it powered up, and then it did the radio test, which passed. This is the one I mentioned. If it fails, it will go into alarm and has to be physically cleared with the acknowledge button by the operator. And then here's the first worker alarm. So here's where the worker got the alarm, and then here's where the worker confirmed the alarm. So it's data logging both of those events. The alarm acknowledge is the train operator acknowledging that they also received the alarm that there's workers ahead. And then the dropout report is when the device has left the work zone and will now clear, because it holds those alarms from the workers so they don't get re-alarmed until it clears that work zone. And then that's called the dropout. And then that way, if that same operating cab is to go through that same work zone later, it will re-alarm the workers. But all this information is stored regardless. So if you had an incident at a certain, on it, which train it's with, typically, you can pull that data log and see, okay, how fast was the train going? Did the worker get the alarm? Okay, why didn't they confirm? Or they did confirm, but they didn't move to a place of safety. You can use it for training purposes and to help mitigate and lessen your near misses even more than the system does already. Here's a picture of a system that was installed aftermarket at RTD Denver. They put it up here. We can usually find a spot to put it, and OEMs will also do the install and build it into the design as well. And this is the charging wall that they designed in their radio cabinet. And this is the directional antenna that goes somewhere on the front of the train as well. Okay, so that's it for the ranging system, and I'm going to move on to our wayside mounted warning systems. We have a permanently wayside mounted RWP system and other warning systems that can be integrated with the train-based or used as standalone. So the TRACCS system is our permanently mounted wayside roadway worker protection system. This system would be, you have units permanently mounted on the wayside so they would require some kind of power infrastructure, but this would detect any vehicle on the tracks. So this would be good for shared corridors where you have different railroads coming down on the same tracks. It'll detect any of them, you know, if you can't put something in your train or in their trains, I should say. And the one of the other things that this system can do, if you want, it's an option, is it can also do location awareness and track where the track workers are in real time based on their personal alert device. So it's going to triangulate their location between the devices on the wayside and send that information back to the control center. And basically for emergency purposes, or if you need to track where your inspections are taking place, or if they want to mark where they've found a defect, things along those lines. So this is mostly what I've already mentioned, designed to be used by all transits and railroads, whether they have shared corridors or a closed system. It'll detect any rail-bound vehicle, and it will alert the workers ahead when there is a vehicle passing the device and triggers the system. Now, since there is, you can add the train-based system if you wanted to, so that you had your operator could still have the information to confirm as well. So this will communicate with the train-based if you wanted your train operators to have that information, even if you have other trains on your railroads that won't get the information, but your workers would still get the alarm. You can add the train-based, or you can also, the wayside system has flashing LEDs. So if you didn't have anything in your train, you would just want to inform the train operators that if you see flashing LEDs on the wayside, that means there's workers in that vicinity. And this is configurable as well. So say the boxes are roughly 1,000 feet apart and you wanted basically the workers would be at one box. Well, the one on each side of that box where the worker is would be flashing. So you'd have 3 boxes flashing. The worker would always be in the middle of those. So if a train is approaching and they see the flashing lights, they know there's a worker, you know, in the middle of those lights. So it's not as exact as far as the distance that's displayed on the train unit, but you can configure this. And if you know how far apart you put your boxes, and you could do, you know, 5 boxes lit up so that you know they will see that with 3,000 feet, the boxes will be flashing when the train gets to the unit 3,000 feet before they reach the worker, things of that nature. I know I'm not explaining that well, but it's a little easier to follow when I show the next picture. This also will data log all those events as well, all the alarm signals, confirmation signals, and also the track worker location information. These wayside boxes also do self-diagnostics. So if a unit does go down or is not communicating, it will bypass, the units they ping each other, communicate, basically handshake with each other. If one is down and not handshaking, the other units will recognize that. They will send an email to the control center or to that email address that's entered in there, letting them know which unit is down, and then it'll just bypass that unit and continue to work as if that unit wasn't there. So we'll just extend that zone for the time being until the unit is replaced or repaired. And I'm going to skip through this because I went over all of this, but these are basically the devices required. This is the wayside device. And this is an application drawing. Basically, it's trying to show that, you know, here's the wayside devices. As the train is passing these devices, it will, the wayside units detect the train, and that's what sends out the signal. And you can, it will know because it's, again, it's daisy chaining this information to each box. So if there's workers way up ahead, it won't start to alarm them until the train passes, you know, the box that, based on your settings. So if you wanted the 3 boxes or 5 boxes, you know, we would work through that and explain that, how to set that system up ahead of time, but you would be able to give your workers advanced, you know, at least 3,000, 5,000 feet advanced warning, whatever, again, whatever you're looking for. And the same here. Yep.
Jamie, Kyle Booth has a question here that I think it might be good to address here. Are these systems SIL rated? Also, what are the options to retrieve the data logs? Any wireless?
Yes, so the systems are not SIL rated. These are secondary systems. So, but they are fully outdoor rated and have been tested and vetted and used at all different agencies across North America. But the data log, so you can get the data log for the wayside-based system through the network, so at the control center, or you can pull it off a unit if you wanted that, but the information is sent to the control center in a data log format. And then for the train-based system, the data log is pulled off that train unit. So if you had an incident with a certain train, you would go to that unit and get the data log right off of with a USB drive. It's not wireless at this time, but future systems may have a cellular card that we can provide. But at this point, that has been, our customers have been very happy with that, because it's a lot of times providing more information through their cellular network and their firewalls, and it just becomes a big project when they really don't look at that data unless they have an incident. And it's a lot, they have felt it's a lot easier just to go get it from that one train, instead of having all of this data pouring in that they don't really use on a daily basis, and then trying to find the data from that one train when there is an incident. So far, though, even if we have or had that option, this has still been preferred. So some of our other wayside-based systems are train approach warning systems. These are systems that can be, we're a solutions provider, and a lot of our customers have come and said, look, we have your train-based system. We have this area where we have a lot of trespassing. For example, MTA Baltimore has a bridge that they have a lot of trespassing on. They already have our train-based system. And so they said, can you just put an announcement system that every time a train is approaching there, it's going to alert and announce that the train is coming. So they just want to give their trespassers an extra heads up, because they know they can't do anything about the trespassing. They didn't want a detection system there because there really, again, wasn't anything they could do. They already have speed restrictions in place. They've done everything else except give the trespasser the notification so they can actually get out of the way. And so that was pretty simple for us, because again, being radio based, we can basically make anything wayside and make any type of announcement that that you could need. So that is a trespass warning. And then we also have passenger and pedestrian warning for platforms and stations. That basically is the same thing. When the train is approaching, it's a nice friendly message saying that the train is, just warning, caution, the train is approaching. And that is also used in many of our agencies where they have pedestrian crosswalks over the tracks to get to the other platforms and things like that. They want to give their passengers and pedestrians an additional warning. Now those systems are passive. They just alert every time the train approaches, whether there's somebody there or not. And then we also have track intrusion detection systems. These are, I feel like I'm running out of time. The track intrusion detection systems are active. They are going to only alert and notify someone if there is an detection made in that danger zone. So for example, in this picture, we've got the intrusion zone up ahead on the tracks. This would be our mounted system that would be mounted up high, our aerial mounted system. We would zone out your specific area if you have theft or high trespass or whatever the case, and you want an area, a danger zone, that if somebody is in there, you want a warning. You want a warning sent to the control center in real time. We can send a text message or an email, and they can actually, if there is any intrusion in this zone, it will do a recording of what's going on, and they can access that immediately via the cloud. This does have cellular capabilities. It's not reliant on that. The cellular is only to send the video. The detection alarms will activate no matter what. And again, bringing it all back and integrating wayside systems with our train-based system. If you have the train-based system, this intrusion system can also alert the train operator via their train-based system that there is an intrusion ahead, and so they can actually stop or slow the train and call dispatch if they're getting that alarm. Let them know, hey, I'm getting this warning. Should I proceed, through the intrusion zone? And that's been very beneficial because they're the only ones that can prevent the accident, right? And because we're using ranging radio technology, we're only alerting the train within their stopping distance. So we don't need to alert the train if they're 2 miles away that there's something in the intrusion zone, especially, because if that object clears, then the alarm goes away. And so the train never needs to be notified. The train operator never needs to be notified unless it's within their stopping distance. And then, that's where they can stop or prevent an accident from happening. And there can also be local alerts. So the picture on the bottom is of a platform where we can also install the LiDAR detection systems. And if someone goes into the tracks down by the platform, you can also have local alerting mechanisms set up, a speaker, flashing lights, and also notification to the attendant booth if you have one, personnel on site. So they know to go and, call dispatch, don't send a train. Or go get the person out, call the police, whatever the scenario requires, we can provide that as well. These systems can be basically installed almost anywhere. So, any area that you have that would require something like this, we can outfit with the LiDAR systems. And they are programmed to avoid detecting rats or small debris. It's programmed to detect people, basically, or very large objects that could, cause a problem being on the tracks. And so it's using LiDAR to do the object detection, and LiDAR is not affected by lighting conditions, rain, fog, snow, etc. Vision systems, cameras are affected by that. So we actually are using both in our LiDAR. In our system, we have the LiDAR for the object detection, and then we are using camera for some AI properties and to do the video imaging and that nature. So it's sensor fusion. So it's really the best of both technologies. So I'm going to move on here to collision avoidance. Our collision avoidant, we have two basically types. We have a radio RF based, and then we have LiDAR based, which is the same LiDAR we're using for one of the LiDARs we're using for track intrusion. For collision avoidance, it's basically our system is designed to mitigate collisions between maintenance of way equipment for both the LiDAR and the RF based, and these can actually be integrated together as well. So the collision RF based works pretty much like our ranging roadway worker protection system, utilizing almost all the same technology, but it's programmed differently. So it's looking for other train detector, other collision avoidance ranging devices and alerting when they come within a certain range of each other. And you can set multiple parameters. So you can say, if you have one on tamper and one on ballast regulator, you can say, okay, first alert me when we're within 100 feet of each other and get one alarm. And if we keep getting closer together, say 75 feet apart now, then I want 3 alarms. Your second alarm gives you 3 audible alarms and notification. And then if you continue to get closer together, say at 50 feet, and that's your danger zone, then the system goes into a constant alarm. And it also tells you if it's the machine in front of you or the machine behind you. And that machine, if it's the machine behind you, they will be getting the same alarm that they're too close, and they'll know it's the machine in front of them. And so then they can, slow down or separate, speed up, whatever needs to be done to separate between each other, and then continue to work at that point. And there's those 3 different zones. There's actually 6. There's 3 in work mode and 3 in travel mode. So in work mode, typically they need to work a little closer together, and they're going at slower speeds. So you can set up your zones to be closer. In travel mode at higher speeds, and you want your machines to stay pretty far apart, you would make your zones a lot further apart. Now, these are using radio technology, and they are only looking for another unit. So that's a limitation of this system, is that you have to have one on each piece of equipment. It will not detect a civilian car on the crossing or something of that nature. It will detect workers within the area if they have one of the personal alert devices. And since this is the master device that you would put the configuration file on your collision avoidance units, you wouldn't be alerting your workers, at 2,000 feet away, because you want them to be working pretty close to the equipment. You would set that parameter for when it's used. Same pad. He can go be 2,000 feet away from the train and get the alarm, or be 50 feet from a piece of equipment and not get the alarm until he's within the 50 feet danger zone around the equipment. So this person can come and go. He doesn't have to change anything. The pad will work correctly because it's the way that the file is set up on the train or the equipment that will dictate when the worker gets the alarm. So you can use these interchangeably with trains coming in or around your work equipment. Now, we also have the LiDAR collision avoidance system. This is a new system that we have just released. We've been developing this for over the past 2 years. We've done extensive testing, and this will provide the object detection. So instead of being radio-based, this will detect any object in front of the equipment or machine. This can be used on trolleys and streetcars, but it only works really well. It can only process the information at up to 35 miles per hour. So it's mostly used for work equipment, but again, streetcars, trolleys, things like that, this would be a really good application for that as well. This will detect cars, objects. This does utilize AI along with the LiDAR, so it's sensor fusion with vision and LiDAR, and we're training it to detect switches as it's approaching a switch, which way the switch is thrown. It's detecting crossings ahead, and it can give the operator that information. It can detect people as well, even if they do not have a personal alert device, and other equipment, other machines and things like that, of course. And you can, if you wanted to use them both together, you could use the collision RF based along with the LiDAR. And the reason you might want to do that is because the RF is going to get a lot further distances for travel mode. So if you wanted to have that, some do want it much further away on their work equipment for travel mode, and others say 300 to 500 feet is fine, even in travel mode. So as you can see in this picture, it's not a great picture, I guess, but it's hard to see that person basically with your just looking at it. And here you can see that the LiDAR has no issue picking up that it's a person there in the point cloud, and they're pretty far out. So the system can be used on both the front or rear of maintenance equipment, or on the front of the street trolley or tram car. I'm just going to read these down quickly and see where I left off here. It will provide the information and warning to the operator if an alarm meets the criteria. And what this picture shows is that we have been training it to follow the track that the machine is on. So in this picture, it's following the track that is shown in green here, and it will not alarm with the person off to the right-hand side, even though they may be, they're clearly in view of the system, but they are not in danger, and so they will not alarm the system. And we're just showing this for purposes of understanding the following the track. The detection zone would bleed over as much as you define that zone. So typically we go a couple feet out on either side of the track. But in this picture, again, it's just to show that it knows what track it's on, and it's not going to alarm with that person that's not in danger or in the way. So it's just a way of preventing false positives. Let's see. These alarms this will also data log everything. It takes a full video of any danger alarm. So your third alarm, it will video that. You can do the same parameters with like our RF system can do. And we'll fully take 20-second video of the alarm, of the danger alarm. If you have that third and final alarm parameter go off, the constant alarm, it will, once that's triggered, it actually is it's basically recording the whole time. It doesn't save that video unless there is an alarm, the third danger alarm trigger, and then it will save the 10 seconds before whatever triggered that alarm and 10 seconds after. So you have 20 seconds to video what happened if you had a collision between machines. And this just shows the alert zones. Track identification, providing track specific alerts. Here you can't even see the person's way up there now. This is a video. I'm going to try to play it. I don't know if it's going to stream very well. And then I think this is my last slide. So we should be just about enough time here to get a couple questions in. In fact, I'm going to skip this video because I don't think it's going to stream well. It basically shows we go past a person who goes out in front of the tracks, and then over here, the operator wouldn't see the video. It would be an option if you wanted them to, but this is basically just to show you what the system's seeing. The picture on the right-hand side of my screen is what the operator would see. If they're all good, it's just green, it's normal. It does track how far away in distance it is to the next vehicle. So it will turn red and make an audible tone when it's within your specified range. And this system allows a MP3 file, so you don't have to it does not have to be an annoying beeping noise, or it can be a spoken alarm, a spoken message, or some other alarm, 3 different sounding alarms for each different parameter. It could be your boss yelling at you to stop the machine, whatever you want it to be. So that's just another option, because sometimes the alarms sound like other things. So this way you can make sure it doesn't sound like any other alarm they're getting, and they know it's the collision avoidance alarm. This is the unit over here, just to kind of show the actual size. This is on our high rail on our test tracks. So, it's very easily deployed, super easy to set up. This does have all of the CE certifications and everything. This is ready to go. So we're really proud of this new system. And that's it. So I just wrapped it up with 5 minutes left. I apologize. Here's my contact information. I'm going to see if I can stop sharing so I can see the screen again.
Jamie, please, I was going to say to please leave your contact info, but we will share your contact information with everyone by email. Rafik here is asking, can you share the presentation? For sure. We will be sending you all an email with further information. So for sure, that's going to be covered. Now, Jamie, I have a question here from Kimia Sakikani. Does track intrusion detection system have the capacity to avoid false alarms, for example, pigeons?
Yes. So the track intrusion system is going to avoid smaller objects. So typically we program it to be something larger than like a beach ball, larger than a basketball is what we've used in the past, but we can change those parameters as well. But we wanted to make sure we got if somebody was laying down on the tracks. And now with we've 2 different systems. One's a little bit more intelligent. The same one that's being used on the collision avoidance can be used for stationary applications, and that will use the AI feature as well and can determine, we're training that every day on if it's a person or, an animal, or, just to ignore certain alarms as well.
Sounds good. So for anyone who has a question right now, feel free to type them in the chat or raise your arm. Your digital hand is right below our faces on the screen. I do have a question here that perhaps you can give some information. Have your customers that use the roadway protection systems provided any feedback on the results?
Yes, we've had really good feedback from our customers, especially those that have upgraded or purchased the ranging system, our newest system. They have seen significant incidents and near misses drop down from prior to using the system. And I can provide industry contacts as well if anyone's interested in talking to those agencies, including Edmonton, RTD, Valley Transit. They've all had really good feedback for me as well. They're very happy with it.
That's great. Mo Baka is asking, is your detection system based on image processing technology?
No. So the track intrusion system is an object detection using LiDAR, and then it does using vision as a backup. So it's taking the using the camera for video and pictures of the intrusion, but also we are incorporating AI properties to determine if it's a person, especially on the collision avoidance side for maintenance equipment. It'll know if it's a person or not that they're detecting, so that it could give a different alarm. So we're using the AI image processing in that area, but the base technology is object detection. So the LiDAR is going to tell you if there's something there or not, where some vision, if it's with strictly vision, it could miss that object. You know, if it was poor lighting or, you know, heavy rain, it could not see it. So, you know, just like your camera, you know, today. So the LiDAR, though, that does not matter. It's gonna do object detection regardless. And that's why we program some of those size parameters. We can program speed parameters into the moving system. So if it's at 0 miles per hour, you're not going to get alarms. So we've put a lot into it to scale it and avoid false positives, make sure we're definitely getting the significant objects that could cause an accident or harm to someone.
Thank you. Brian Telm is asking, with the pairing of technology-based worker protection, are there any demands for physical barrier for adjacent track protection or general pedestrian deterrent for and around track access points?
So for the first part of the question, with our roadway worker protection systems, you would not need, I mean, I don't know if you would need physical boundary at that point. Right now, the system is just telling the workers, though, that a train is approaching. It will give them different alarms for when a new train approaches. They can set up adjacent work zones and get different alarms in that scenario as well. But if the worker left the work zone, and they would still get the alarm if the train was going to hit them. They don't have to be in the work zone to get the alarm. So that is a common problem where a worker doesn't realize they've left the work zone, and that's where a lot of incidents do happen. And in this case, if they had this on, they would still get the alarm. They would know that a train is within a certain, you know, 20 seconds from them or whatever their file is. So this would help protect them even if they've stepped out of their work zone by accident.
Okay, Brian, if there is follow-up, you may unmute yourself and ask away. I guess that's fine. We have Terry Johnson's question. Can the intrusion detection system, are the intrusion detection systems suitable for grade crossing protection at higher speeds? And could a version of the worker protection system be used for protecting rarely used farm crossings?
Can you repeat that one more time?
Yes. Are the intrusion detection systems suitable for grade crossing protection at higher speeds?
Yes. So that's one of the things we have not started to really advertise yet, but the track intrusion detection system can also be used for occupied crossing detection. So if you, in multiple ways. So we can, if we have the LiDAR at the crossing, it can detect if there's something dwelling in the crossing, and an alarm, send notification to the approaching train, again, when they're within a certain range. And vice versa, if the train is approaching and it has a train unit on it, it can also send a signal to the system at the crossing, letting them know to announce and light up a sign. We can actually trigger a written LED sign with our system. But yeah, we can send the notification and warnings both ways. We can detect if something's there and send that information to the train, or we can also use the train, use the train to send notification to the crossing system to announce at the crossing or light up a sign to say train approaching. So if anyone is approaching it and there's no already signaling system there, this could definitely be used in place of that. And high speed is not an issue for this system. We can test 2-3 miles of communication with no problem. So,
Thank you so much, Jamie. We are at the 1 p.m. mark. We've received some messages thanking you for your answers, for the great presentation you've given. We are most grateful on TRACCS, so thank you for your time. Thanks everyone who attended. Please make sure that you subscribe to our, join our newsletter so that you never miss webinars like this, because you don't want to miss them. This has been great. So if you have to jump on the next meeting, we will see you at the next webinar. If Jamie, if someone wants to ask another question, do you have a few more minutes?
I sure do. Yep.
Okay, fantastic. So thanks everyone. And someone raised their digital hand. Was it, I can't see now. Give me a second.
By the way,
yeah. So, okay. So they raised, they put their hand down. But if any other questions come up, you can type them in. And as we mentioned, we will be receiving information and the slides. So rest assured, you can ask Jamie all the other questions you may come up with after the fact when you talk to your teams. Again, thank you, and we're looking forward to having you at Rail Day, Jamie. I know that you'll be having you have a booth. I believe it's in 332. Was it?
I meant to check that before.
Yeah. Oh, it's 334. So if you want to meet Jamie in person at the show, it's booth 334. She will be there with the rest of the PROTRAN technology team.
Yes.
Thanks again. And
thank you, Andrea. Thank you, everyone. Hope to see you at TRACCS.
Yes, you will. Definitely.
Thank you, Jamie. Looking forward to seeing you at TRACCS Rail Day.
Perfect. Thank you.
Okay, bye-bye.
Bye.